Hi, welcome to Layman's Guide to Cracking the Coding Interview. I'm Jox, and today we have a fairly mid-level problem, but not too complicated. Just need to check two more conditions or the comparisons, then it's gonna be easier. So here's our problem. So we are given the input array, and we need to find the maximum volume in the container to fill the water. For example, if this is the given input, so we need to find out the maximum volume that can be created with using this as a volume. So for example, we have an input as 186254837, right? So in this case, each consecutive movement would be 1 unit, and each height gonna be the 1 unit. For example, if it's a 1 at the beginning, so it's just gonna be a 1 unit, and then it's gonna be 1 unit in the length. So we have a length and the breadth, but we are talking about the volume, but it's just gonna be the area, but it doesn't matter. We just need to consider this as a volume, assuming that the length and breadth are same, just the difference is with the height. So in this case, we have a first index 0 as a 1, so the height is 1, and if we compare with the another one, the max is 8, but the first one max is 0, so we can take max as a 8, so we should take the minimum height as a actual height, and then we need to create find the area or the volume for that. So in this case, it's going to be 1 and 1. So I have a pretty good example in the next slide. So this is our example. So I created the input as 2384237767. So in this case, we have a first index as a 2 and the second index as a 3. So first we need to consider this first two indices. So in that case, we have a single length and the minimum height. So that would be 2 and the 1. So the volume, max volume, if we just have these two, then would be 2 by 1. So that's a 2 unit square or the 2 unit cube. So let's do that first. So we have the minimum height, right? So we need to take the minimum height because we can't take a max height, because if you have a max height, the water gonna overflow. So we don't want to overflow that. And if you have an overflow, then we'll just have an error. That would not be the max volume. So in this case, we need to take a min volume of the container. So we assume the given input as a container. So we have a first index and the second index. So that's 0 and 1. So we take a min 2, right? And once we have a minimum height, we compare the volume. We get the volume. So here we have a max volume as a min height and the product of index at 1 minus index at 0. So we take the, as I mentioned, we have a consecutive indices have a length of 1 unit. So in this case, we just have a 1 unit and the max volume would be 2. So we have the volume for the first two. Now we start with the third indices. So that's going to be index 2. So from here we continue. So this is how we continue. So we have a first volume as a 2 unit square or the 2 unit cube. And this is the value. So let me go through the second iteration. So this is the case. So now we are at the 8 or the second indices. So we're taking the first, we're comparing mean height for 8 and the mean height for 2. So obviously the mean height would be the 2. So we have a 2 and 8 comparison. So we have a mean height 2. And then we need to get the length. How far is it, right? So from here to here, 1 unit, 2 units. So that's what we do. Indices 2 minus indices 0. So we have a, in that case, so 1, 2. So we have a 2 and then the height is 2. So the max volume, like in this case, we put things in the temporary volume, right? Because we need to compare with the previous one, and then whichever is the max volume, we make that as a max volume. For now, we just compare with 2. So we need to compare with 3 as well. So we do that for the 3. So the max height from 8 to 3 would be the 3. And then the length would be just 1, because index from 2 to 1 is just 1. So 2 minus 1. So we have a volume as a 3, in fact. So I think this should be 3. There was some error. Okay, so this is going to be the temp volume. So we need to compare which one is the max. So in this case, 4 is the max, but still this is not the global max volume. So we need to compare with the previous one, this container. So in that case, the max volume would be 4, however, because the previous one is just 2, the second one is 3, and the max is 4. So here we have a max comparing with the max volume previously 2 and the 4. So we have a 4 here. So we repeat this process from this iteration from second indices to the end of indices. So now we have a, in the second, this is the max volume. So we just remove the previous one. So this would be the global max for now when we are at the second indices. So we go through the 4, 3, 2, 7, 6, and 7 again. So in that case, we'll have a max volume would be somewhere between 8 to 7 because we have a unit length of 1, 2, 3, 4, 5, 6. And the height would be 7 because this is the mean height between 8 and 7. So 7 by 6 is 42. So this is the max volume. So we're going from second indices to the end of the indices. So that's a 42. And as we notice that every time whenever we add any indices, we need to compare with all the elements that's on the left hand side of that. So that is, we are doing n square of the runtime in this case. So let's run the program. I have written the program. Whatever I just described over here, it's in the program here. So we have the same input as a given container, and I name it as a container. And then at first we need to check whether the container or the given input is of length 0 or the length 1. Even if we have just single length, then we can store the liquid or anything like a water. In that case, we wouldn't store anything, so we just simply return 0. If we have at least 2 values in the given container, then we can have the volume for that case. So we, as I mentioned earlier, we have a minimum height as the indices 0 and the indices 1. So here it's going to be 2. And then we repeat the process. So you see the 2 for loops. So it's O(n) square of the runtime. So this is a little bit, time consuming, but I think this is the only way to do. But if you find any better runtime, you can just let me know down in the comments. So I'll just kind of run through this program. So we have a 42, and I want to run the second one as well. So this is the input. This one is the one that's in the questions earlier. So I'm gonna run that. It's gonna be 49. So it's 49 because we have 8 and we have a 7 here, and the mean height is 7, and the distance would be 1, 2, 3, 4, 5, 6, 7. So 7 product of 7 would be the 49. And I want to show you like when we have a really long n, so how slow would it be? So I'm just gonna run and look at the time it's gonna consume. See, it took us like about 7 seconds, and let me see how many items are there. I just wanted to check the length. So we have a 5,000. With the 5,000 as an input, it took 7 seconds. That's pretty long. So, what I'm trying to show here is once the n increases, how slow would be the runtime for O(n). It's pretty slow. So that's just what I wanted to show. And if we find anything better than this, then that's going to be amazing. And thank you.